Hello everyone. In this session, we will have a small discussion on contamination happening in IC fabrication and its effects and sources of contamination and all. So before going to that, normally right, our ICs which is fabricated because of contamination, it will have high resistance. Okay, because it will block the flow of current and it will have some other effects. So your resistance will be high if there is any contamination. So before going into the topic, we'll have a small discussion, and that is about what are the effects, that is contamination effects occurring in modern ICs. What are the issues that are occurring in modern fabrication of modern ICs? You can start.
Extremely small sized features. Modern IC have a nanometer scale transistor and metals which are interconnected with the NM technology and MOS. Even a small and a single particle or molecules can block and short the tiny lines. Let us take an example. That is dust which is just a few nanometer across, which can disturb the metals. That is even only a few 10 miles above the nanometer.
Okay, good. Normally, the ICs, right, it's fabricated, modern ICs, it's fabricated in nanometers. If there is some extra materials or something, it can also affect the process. So that's the thing. So what is the next issues you are facing?
Highly sensitivity of electrical properties. Contamination can increase resistive or capacitive effect. Metals interconnection with residue or oxide have a higher resistive, which is slows down
the process of the IC. Yes, good. So normally we have discussed, right? The first thing I have said, because of contamination, there will be increase in resistance. So here is the thing: there will be increase in resistance as well as we will have some capacitance issues occurring there. Okay. So what about the next one?
LBT concern. In that contaminant can trigger electromigration. In that it will fail occur and device may fail prematurely even if they initially works.
Okay, there will be some aging problems occurring because of this. Okay, so it will be the working aging, right? It will be not be valid till that point. So that's the point. Next one.
Even the minor contamination can enter in the reducing and the manufacturing field. Lower manufacturing.
Okay, so the yield and cost thing, right? So yield is about the protection. Okay. So if there is a minute problem in your circuit, minute contamination, will be manufacturing in bulk. So it can cause huge impact on your production. So that's the important thing here. And next one.
The modern fabrication and multi-layer. In modern chips has multiple layer chips has tiny layers and patterns. The contamination can be affected the multiple layers. Then
Okay. So this is the thing. Please. Thank you. So if the problem of any contamination is occurring on one layer, if it is a multi-layer device or multi-layer fabrication ICs, so if it is contamination is occurring in one layer, it can be affected in the other layer as well. Okay. So this is that. Next is about the effects of contamination in ICs, right? Yeah. Common system. Now we'll discuss about what are the sources of contamination that can be occurring in the device. So what are the possible sources that can be affected by the contamination?
The common sources of contamination. The common sources of contamination, particular contamination, dust, fibers, steam flakes from operators. It's about metallic contaminations, unwanted waste from tools and deposition position. Next about the chemical contamination, residues from ejection, photoresist, solvents and acids. Next about the
Okay, thank you. So, for example, the fabrication is done by the process. We are doing many processes like photolithography, okay, and we are cutting it. We are etching the particular part, right? So, for example, when we are for photolithography, we are using photoresist material, right? So, there will be some residues of that material will be left on the layer. So, this can be possible sources of contamination. Okay, and if you are cutting any particular part or we are etching any particular part, if you are not cutting it properly or not, you are not etching it properly, that can also be the one of the source of contamination. Okay, so next, what are the effects of this?
On device and the circuit performance, first one, increased resistance in metal lines that contaminants can create a thin insulating layer or localized defects. And the second one is open circuit or short circuits. Particles may create a short between lines or blocking connections. Then device reliability issues and long-term.
Okay, so thank you. So for example, if there is any metal part which is left on your device or left on your ICs, okay, if you are keeping it without checking any in prior, what happens is there is a possible of short circuit occurring because in the everything is in say simple ICs, right? So if you are not checking the contamination, there is a possibility of short circuit happening in the device. So now comes how we can avoid these processes. What are the prevention can be done? Yes.
Prevention methods are wafer cleaning, RCA clean, pyroma clean, DI water dryness before metal deposition, equipment clean, and tool cleaning, controlled chemical handling, pure chemicals, filter solvents, deposition technique. Use of high vacuum system to reduce airborne contamination.
Thank you. So listen, we'll have some good methods to clean it. Okay. Before setting on the wafer, we'll be cleaning it in without any impurities. Okay. And after every process, we have to clean it and we have to check whether the contamination is clear. That we should be made it possible. It should have no contamination. So this is how we will be eliminating the contaminations in our ICs. Okay. First, we have updated what are the problems and what are the sources and effects and what are the preventive measures. So this is not only because there is a problem occurring in the single step. Normally, ICs fabrication will be done in bulk. That is one big disadvantage. We will be producing it in bulk order, not in a single chip, not single ICs. We will be fabricating it in a bulk thing. Okay. So if there is a single mistake done, there will be more losses because we are fabricating in n number of ICs at a time. So that's the reason contamination should be noted very frequently. Okay. So that's all with this case study. Thank you.